So welcome to Scene and Solve, presented by Hubbard-Hall. I'm Tim Pennington, editor of finishingandcoding.com. And today we're going to be speaking with Jerry Dwyer from Hubbard-Hall, and the topic is heat treating.
You're listening to the Scene and Solve podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
Jerry is the Hubbard-Hall's market manager for heat treating and black oxide. Jerry, I know I've talked to you a couple times, but always good to talk to you again.
Good morning to you, Tim. Good to see you.
I think the last time we talked, we were talking how many decades you've been in the heat treating industry. You want to update us for?
It's been about 3.5 decades, almost 35 years.
Wow. So what's different from day one when you started? Is there anything that's really changed since the first day you were in this industry and kind of a newbie and trying to figure it all out and wondering what the heck they were doing or trying to do?
You know, if I could say if anything's changed, even from 35 years ago, things have always seemed to consolidate where businesses keep getting larger and smaller companies get folded into them. And it seems like, but as far as the industry, we're going to be talking about salts today. And that was always predicted to go down in production numbers, but it was just the opposite.
Yeah, I was going to say it doesn't.
Salt keeps growing.
Yeah. Why is that? Why do you think that is? Is it the alloys that people are using?
Yeah, it's the most efficient way of heat treating for os tempering. It's the most efficient way of energy, materials, etc. And it is ideal for os tempering, using salt as a medium.
Yeah, I was going to say, are manufacturers looking to treat more parts now than before, do you think? Are they seeing a greater benefit into, kind of doing that process along the way? Or
I think it really comes down to, to specific industries that are kind of geared towards having their parts os tempered. And that I can't really gauge the activity out there. I just know that my customers are busy and it does seem to keep growing.
Right. Well, good. Yeah, good. Always good when we have manufacturing occurring here in the U.S. and keeping it hustling and bustling and keeping it going. So that's good to hear. When people ask you, why should I heat treat my metals? Why should I heat treat my parts? Kind of give us a background, what the answer you give them, and why are people doing that?
Well, when steel comes into a factory, it's malleable. You can form it, you can stamp it, you can punch it, you can do all sorts of things to shape it into the item that you're desiring. And the heat treating process actually gives it the physical characteristics that make that tool, if you will, practical. It'll give it a certain hardness so that it's functional.
Is there a size limit of what you could do on some of this for heat treating? Or, how big of a parts have you seen that have been done that?
There is no size constraints. I've seen huge parts get processed. Some of these systems out there are quite huge. In fact, one company had to actually remove the roof of their building to lower a tank in by crane. So it can get quite large.
Wow. And I guess in your business, that's pretty exciting to see sometimes. You get big things like that, get those on there. So we talked about salts. And so why are salts used in this process? Why use heat salts? What does that do?
There's a couple reasons that I can think of. Number one is it's a great medium to preserve the shape of the work that's being processed. The salt has a certain buoyancy, if you will, and it kind of encases the work to hold its structure as it's being processed. And also it's just a wonderful heat medium. It's a great conductor of heat, and it surrounds the part uniformly so that the part in every area is getting equal temperature to it.
Right.
Also, too, when you get into the Aus tempering, you get the high heat, and then you get into the Aus tempering. The Aus tempering is in a range where when you're Aus tempering a part, you want it at a certain temperature range, and salt is ideal to obtaining that range. Whereas quench oil might be too severe, and or water quench will be too severe for the desired characteristics that you want out of the steel.
So are all the tempering salts compatible, I guess, with, I guess we're talking different alloys and everything. Are they all compatible or no?
Tempering salts, yeah, they are compatible. The only real difference between their nitrite based chemistries, and the only difference really would be the melt point. Typically the operating range is about the same. You can take the salt up to about 1100 degrees Fahrenheit before you start getting into some difficulties. So it's got a wide range, but there are different blends that will give you different temperature melt points and ideal operating ranges.
I'm sure you've probably seen situations where you've been kind of called in and to fix a problem. Is it the fact that maybe they're using the wrong type of salts on a particular part, or?
Not typically, no. If there's a problem, it might stem from, parts are soft, which could be high oxides in the high heat system. There's a lot of different possibilities in heat treat where you could have some issues. But typically it's pretty trouble free, really. As long as you maintain temperature, not too much can go wrong, really.
So let's walk me through the heat treating salts. What types are there? How are they used? Those type of things.
Yeah, if you're doing a salt to salt operation, so basically everything is processed in salt. The first system will be your high heat salt. And now this salt is a mixture of chlorides, and it'll get the temperature of the salt up to 1650, 1700 degrees. And that's where the hardening actually takes place. Mm-hmm. The steel is placed into the tank, the high heat tank, and its parts come up to temperature, and you get into a certain range, say 1400 degrees or so, where the parts actually chemically start to change chemically. Actually, it's a little bit complicated, but you get into a transitional phase where the parts kind of reposition the carbon, and they come into a harder structure, if you will.
Right.
And then after that, they're quickly moved into the tempering tank, which will quench the part out, which will cool the part, and put it into wherever you're setting that temperature. We'll put it into a certain range where you're getting desirable hardness out of the work and ductility. So it's really what the part calls for. And that is all pretty much automatic. The operator knows where to set the temperatures and limits to get the desired characteristics of the work being processed.
When they're quenching parts and doing those things, that the carbon and the metal transforming, that all stops. Is it almost right away, or is it still going on?
It's not that lengthy. The high heat phase might take up to 10 minutes. Parts come up to temp quite quickly. And then they flip into the Aus tempering. They'll cool pretty rapidly, depending upon, of course, the reservoir that you have and so forth. But it's a lot quicker than you might imagine.
Right. I didn't know if it was like my steak that I take off the grill and they say, well, it's still cooking, right? It's still the molecules in there are still working, but
you can quench out. You can leave parts in the quench at that temperature. Say it's set at 450, 500 degrees. it's not going to harm the part, leaving them in the quench. But you want to just quench it quickly, get it into that proper range, wherever it might be. And sometimes, that is, you asked before, what are the differences between a salt? Sometimes a customer will use a low melt point salt so that they can get that quench a little harder, if you will. They can get the temperature lower so that the parts come out a little bit harder. And by doing that, you sacrifice a little of the ductility, but it all depends upon how that part's going to be used, what its purpose is. And again, the operators know what they're doing, and it's all pretty much pre-engineered.
Right. Is that process still the same that over the last decades? Have you seen it where it's pretty much stayed the same, hasn't it, a little bit?
It has, yes.
It sounds like just being on top of it, had procedures in place, following it, knowing what you want to do and how you want to do it, and sort of following repeatability, right? Just keep doing it the same way.
That's correct.
That.
Yeah.
Don't deviate with that. Let's talk about rectification of the high heat. What does rectification do in a high heat bath, and what should facilities go about adding pellets and those type of things?
Right. Rectification is really to correct an oxide issue. Mm-hmm. And oxides can be generated over time just by the air and salt interaction. And also, too, if the parts are oily that are being processed and not cleaned properly, all oils are alkaline. So that gets carried into the high heat bath and could pose problems over time, where we call the high heat bath a neutral salt bath. Mm-hmm. And basically, when you start introducing oxides, the pH, if you will, just to simplify it, the pH or the oxide level will increase. And that can be detrimental when you're processing heat treating work. And so you want to rectify that, if you will. Mm-hmm. And the way you do that is a simple acid-base determination. It's real simple chemistry. You just take a sample, you determine the oxide levels, and then you'll have a chart basically telling you really how many pellets it's going to require to bring that bath back to neutrality.
Okay. We've talked in the past about desludging. That could be something that crops up sometimes that facilities need to take care of. So what are some of the best methods you recommend for a facility to desludge a high heat bath and a tempering pot?
Yeah, the high heat bath, you will build up, iron, metal, particulates that really should be removed because they do contribute to the oxide levels in the bath, the high heat bath. So those are periodically scooped out, if you will. There's various methods depending upon the tank configurations and what they have available, but that is not done as frequently as cleaning out a tempering bath. The tempering bath has the chloride salts that are carried over from the high heat. And there's a solubility limit to where you're going to start building up chlorides in the bottom of the tank. And they build up to where you need to take care of them. You have to desludge that tank. And it's done various different methods. Some companies will put a tray at the bottom of the tank, and after a period of time, a hoist will carry that out and remove the chlorides that way. Sometimes they'll have an automatic system to where it's just simply the sludge is directed towards a carry-out mechanism, and it's constantly just being wheeled out. And some others will use kind of like a clamshell device that will scoop up the sludge and carry it out that way. So there's many different ways of doing it, several different ways. And it all depends upon space constraint, how active the tank is, and so forth. most customers have it figured out. We don't get too many requests for any kind of help with desludging. Once in a while, though, we will get samples in just to look at the sludge to see how much good salt might be getting carried out and wasted. So we are called in to help on those situations.
So what do you offer, you and Hubbard-Hall, what do you offer as far as products and services to a lot of these heat treatment places? Obviously, you offer salts and chemistries, right, to help them process. What else do you do with them?
A lot of the heat treaters, they're very educated people. They don't really consult with us for setting their temperatures or anything like that. It's all engineered and they know what to do. When we're contacted, it's basically just to do routine checks on the bath chemistry, make sure everything is, set to normal standards. Salt's checked once in a while to look at the solubility of the salt itself, how much more chlorides it can tolerate, so forth and so on. It's just, there are some various reasons why they'll send a sample in, but it's few and far between. It's pretty, salt's a very easy chemistry to work with. Mm-hmm. And we don't really get a whole lot of technical requests to help out. But we do have a PhD chemist on staff that will do all the testing. It is a free service for our customers. We're at their disposal. So we're happy to help in any situation. And, there's things that come up and we're there to help.
So Hubbard-Hall, really, you all offer salts?
We have the whole gamut, all the salts. Oh, I'd say there's at least 20 different products. Yeah, high heat and tempering. And, high heat, too, we're talking about the chlorides, standard heat treating. But when you get into specialty high alloy steels, they'll use barium salts, which is maybe 3-5% of the market. But there is a different category of salt users that we do have, the whole complete line of products for that industry as well. We get involved in aluminum heat treating. So I'd say, off the top of my head, we probably have at least 20 different products.
So talk about that a little bit. Differences and advantages of those products. How would you go about recommending one or the other for customers?
Well, in the past, it had a lot to do with the economics. A lower melt point salt used to cost more than those that had higher melt points. Mm-hmm. And typically with the market situation now, that might not necessarily be the case. But let's just look at the past. And in the past, if a customer wanted to spend the extra money, which is, we're talking just a matter of cents, but to spend the extra money to get a lower melt point salt, the advantages of that is economics. When the parts are processed with a lower melt point salt, you're going to have more time when the parts are withdrawn from the salt for that salt to drip back into the tank before it freezes onto the work. So you're saving chemistry. You're also doing that if they have idle time in the bath, say on weekends it's not used, they can lower the temperature to salt lower, not to the freeze point, but they have that lower capability of getting that temperature down to save energy when it's not in use. And third, the customer might want to have, as I mentioned, a more severe quench. And so if you have a lower melt point salt, you could quench parts out at a lower temperature to get better hardness, getting closer to the martensitic range, so that parts are nice and hard and still have ductility. So there's three really main advantages of having a lower melt point salt. The range is the same, but you're paying couple cents more, just at least in the past you did, to have those benefits.
With a lot of those, like I said, different varieties, everything, it's good to have someone like you kind of help direct them in that direction of finding the right one to keep production going, get it up and going, and keep it going forward. What's the longest customer you've had for that you've been selling over the years? Have you had them?
Oh, I've been working with some of these accounts for probably 30 years.
Ah, really? Right. Okay. It keeps working, right? I mean, it just things are working good with that. Great. I mean, are you finding where would you see a new facility open up? Is it because it's mostly, I'm assuming, where it's got to be done where they make the parts, right? Or am I incorrect with that? It goes from making the parts, they go right into that, right?
New facilities are kind of few and far between. Mm-hmm. You have such great job shops out there that if you're not really concerned about having control over your work and you're willing to ship out, which most people do, then like I mentioned before, these heat treaters just continually put in more systems and get larger and larger to deal with the influx. But as far as some customers in the past were doing that, but they decided to have control over their own work and time and quality. So they have, spent the money to set up for in-house production, and it has worked out quite well for them.
Right. What's the footprint that usually that would take? It seems like a lot, though, doesn't it? Or is it not?
It's not huge. It's almost typical of any other, like a plating industry or something. It's similar footprint. It's just tank size. You have to find a spot in the plant that's a little bit isolated from other operations. And, some companies will put up shielding just to keep the heat contained and optimize safety. So there are some considerations, but I can think of many, many people that do have their own heat treat operations and manufacturing capabilities at the same location.
Right. Yeah, like you said, that control is imperative sometimes, especially with now, you don't want to put parts on a truck and ship them, wait for them to get back and things.
True.
So really, they have that control is really a huge advantage. Well, listen, Jerry, I appreciate you taking time and again explaining all this to me. It's always been a fascinating, to see those the quenching process and everything take place. And I know whenever I'm in a big high rise, I always think I hope they use Jerry's products when they strengthen the steel. It's always you get into situations you're like, wow, I really hope they use that here.
Well, again, Hubbard-Hall, we have, I think, 37% of our personnel are employed for customer service, and including myself. So we're always at anyone's disposal. We're happy to answer any questions that they might have. And again, we delight in servicing our accounts.
There you go. For many decades. So anyway, great. All right, Jerry, thanks again. Thanks for joining us today on Seen and Solved. And again, people want to watch other episodes that we've had, they can go to Hubbard-Hall.com and watch those episodes.
Thank you, Tim. Take care.
The Seen and Solved podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media.